Okay, so this little video is all about half-life and looking at what half-life is. So we start off with thinking, well, what is a half-life? So we start looking at our sample. So our sample is made up of lots and lots of different atoms, okay? And if we're looking at a radioactive sample, we're going to be dealing with lots and lots of unstable isotopes in there. And they're going to start decaying to become more stable. So remember, that can be by emitting an alpha particle, beta particle, or a gamma ray. Okay, so if we start looking at the half-life is the time it takes for half of the nuclei to decay. So the half-life is the time it takes for half of the unstable nuclei to decay. So this can take lots of different times depending on the type of samples. They can have lots of different half-lives ranging from a few seconds, few minutes, to hours, to days, to even thousands and thousands of years. So we might start off with them decaying, and eventually when half of them have decayed as we go through, okay, so if we kind of imagine these red ones being our ones that are decaying, when we get to half of it, that would be our half-life, okay? So when we're measuring that half-life, we might have lots of different things that we could be measuring. We could be measuring it as the percentage of what's left. We could be doing it as the mass of the amount. We could be doing it as the count rate, so we could be measuring the activity. Okay, so there's lots of different things that we could be doing. I could even talk about the number of nuclei that I have left. Okay, so when we're then dealing with this graphically, which is one of the easiest kind of ways that we do for interpreting half-life, is we might have lots of different things on this axis. So I could have the percentage of my nuclei. Okay, so at the beginning we had 100%. Okay, I could have had the activity, so that would be my main kind of count rate that's coming off. So when it's really undecayed, we've got lots and lots of high activity. It could be the mass of the undecayed nuclei. It could be the number of undecayed nuclei that I've got on the top. Okay, and so a half-life, remember, is time it takes for half of the unstable nuclei to decay. So if we then say up here that this one was 100%, okay, what I'm going to go down to is I'm going to go down to my 50% on my graph. Okay, so if I start at 100, it's going to be going down to 50. And all I then do for my graph is I draw a little line across to 50. And then I'm going to mark it down. Now let's just say, for example, my time here is in days, and this is 2, 4, 6, 8. Oh, apologies. That's my cat. So that was 50%. So my half-life, okay, I'm just going to write half-life as T as a half, okay, is 2 days for this one. So one half-life equals 2 days. Now what we then find is actually this gives us an exponential decay. So if I half it again, so this time round I'm going to go back and I'm going to start decaying until I get down to about another half of my undecayed nuclei. So now I'm going to go down to 25%. Okay, and if I go along to my graph and I go to 25%, you can see that 4 days have passed. Okay, so this is our half-life here. We can then see we've now had 2 half-lives have passed. Okay, so 2 half-lives, okay, is going to be 2 lots of 2 days. So that gives me 4 days have passed for it to have gone down to 25%. Again, if we half that again, all right, so again, we're going down to halving it another time. So again, I'm going to go down to another half, so that's going to take me to 12.5%. If I take myself to 12.5%, you should be able to see that I've gone now another half-life, okay, in this case. So now I've had 3 half-lives have passed. Okay, so that's 2 lots of my 3 days. So I've had a total of 6 days to get down to 12.5%. So we've had 3 half-lives. So a half-life is equal each time. Okay, and each time I'm halving the amount. So if I went again, I would get down to 6.25, and you would see that then 8 days have passed, or 4 half-lives have passed. So 4 half-lives, let me decide, would be 4 lots, or sorry, 2 lots of that should say 2 days. No, that should have been, sorry, 3 lots of that. That should be 4 lots of that. So that's taken as 2 by 8 days. Okay, so in this case, we've had another half-life passing. So 1 half-life was equal to 2 days. 2 half-lives were 2 lots of 2 days. 3 half-lives was 3 lots of 2 days. And 4 half-lives was 4 lots of each day. So 1 half-life is always 50%. 2 half-lives is 25%. Okay, 3 is always going to go down to 12.5%, and then we're going to be going down to our 6.25%. And we call this an exponential decay. All right, so an exponential decay graph. And so we can interpret it from our graph to work out what our half-life is. So a couple of little different things that they could be asking you. They might ask you things like initial amounts, or they could ask you how many days have passed, in terms of like if we've gone down to a quarter of what we initially start with. So a quarter, remember, means that we've had 2 half-lives. So we can start looking in terms of like the fraction and what's remaining. So if I want to know what my fraction is that's remaining, okay, we can actually use another little equation for this, and that's 1 over 2 to the power of n. And n is the number of half-lives. So I'm just going to demonstrate that for you guys here. So if 1 half-life has passed, that's 1 over 2 to the 1. So that's 0.5, so that's half of it, okay, which is 50%. If I had 2 half-lives have passed, that's 1 over 2 to the power of 2. So that's 0.25, or 1 over 4, so a quarter, so 25%. Again, if 3 half-lives have passed, that's 1 over 2 to the 3, so 0.125, or 1 over 8, so again 12.5%, etc. You could also kind of use this for finding like the original mass of something. So if we had original mass is actually equal to the final mass multiplied by 2 to the power of n being our number of half-lives. So let's say my final mass was something like 10 grams. Okay, so let's say that's the final. And let's say that was after 5 half-lives. Okay, what I would do here is I would do 10 times 2 to the power of 5. So if I get my calculator and I say that's 10 times 2 to the power of, I meant to press 5 there, not 3. That would tell me that I started originally with 320 grams. Okay, so I can also use it to find out the original mass. And just remember as well, the number of half-lives is equal to the total time divided by the half-lives. So for example, if the half-life was equal to 2 minutes, so if I was wanting to look at how many half-lives had gone in that time, how many half-lives have there been in an hour? So in this case, an hour is equal to 60 minutes. Okay, so I have to want to work out my number of half-lives, so that little n up here. In that case, I'm going to say, right, I've got 60 minutes, divide that by 2. Well, in this case, I've had 30 half-lives have passed. Okay, so 30 half-lives have passed. So if I wanted to know what the fraction is that's remaining after this time, okay, I would do 1 divided by 2 to the 30. All right, so if I do that again in my calculator, 1 divided by 2 to the power of 30. Oops, sorry, I'm not quite showing that on the screen there. Okay, we have got a, nope, sorry guys, I've just managed to change that off my calculator. Sorry, let me do that again. 1 divided by 2 to the power of 30. No. Oh, sorry everyone. 2 to the power of 30. So in this case, I have 9.3 times 10 to the minus 10. Ooh. Okay, so 9.3 times 10 to the minus 10, which basically means I'm going to be going down 10.0, so I'm going to be getting 0.00000, carrying on. So it's easier to write it in terms of 10 to the minus 10. So I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 3 remaining as a fraction in terms of like what I've got left. So a really, really tiny amount after 30 half-lives there. And apologies for that typing in the incorrect there and the cat jumping up, but just hopefully that shows you how you could do some kind of more complicated calculations with this.